Lab Report on Oscillation. So the purpose of this lab is to investigate the motion of a spring mass system with the mass oscillating by spring and swinging in an arc. So system is mass and spring in this experiment, and surrounding would be the Earth. So if I give you a brief preview of the result, the system's total energy remains constant 0, and the predicted and observed motions models are pretty much similar, and the experiment demonstrated the energy principle. So there's two fundamental principles. First is the Newton's second law, which is the system's change in momentum is proportional to the net force applied, and energy principle. So the change in energy of a system is a work by surrounding on system plus exchange in thermal energy. And you can see the equation on the right side, but there's no exchange in thermal energy in this experiment. So this is the observed motion by tracker. You can see two different graphs, but let's just focus on the Y graph, and we will discuss X later. So if I do the tracker analysis, the period will be 1.488 seconds, and I use that to calculate the spring constant K, which is 7.17 Newton per meter, and then the initial length will be 0.151 meter. So I input that as an initial condition in the computational model, as you can see in the left two screenshots, and the right screenshot is the lines for string length and system energy. So this is the while loop of the computational model. As you can see, I defined the initial energies and calculated the gravitational force and the spring force. So I added the two force to make the net force, and I applied the momentum principle to update the spring position. And then as you can see, I finally calculated the energy change. Since it is a while loop, it'll repeat till the end. So if you see this observed and predicted motion, overall, the experimental predicted one kind of underestimates, and the actual model is more much in the Y position, but it's pretty much similar, as you can see. So possible errors. First is complete exclusion of work done by surrounding. In reality, there will be some work done from the surroundings. In hand tracking, since I manually selected the point mass in each time frame, there must be errors in the process. And third is rounding errors. Since I rounded the calculation to the 3 decimal places, there might be small errors in the process. So is the energy principle satisfied? Yes, there is no external forces that affect the system. Thus, the change in energy must be 0. The orange line shows the total change in energy is constantly 0. And second, compare the oscillation periods. If I use the X graph, I could get the period 1.646 seconds, whereas the Y thing, I get 1.488 seconds. So choosing different directions produces deviation in the period, which ultimately affects the spring constant and the graphs. Thank you so much for watching this presentation.